Question 1. Expand minus 6 outside of d plus 5. To expand an expression, we multiply the front term by each term inside the brackets. We'll multiply the minus 6 times the d, get an answer, and then the minus 6 times the 5 and get a separate answer. So minus 6 times d is just written as minus 6d. Minus 6 times a plus 5, a minus times a plus makes a minus answer, and 6 times 5 makes 30. So that's our final answer there, minus 6d minus 30. Question 2. State the maximum score from the box plot below. So on a box plot, the maximum score is just that little notch right at the end. And in this case, it's just read off. 62 is our maximum score. Question 3. Solve m over 6 is less than 3. To solve an inequation, we use the same methods as solving equations, except if we multiply or divide by a negative, the direction of the inequality sign changes. So here we want to get m on its own. It's being divided by 6 at the moment. We need to do the opposite of both sides. If we want to move that dividing by 6, we need to multiply by 6. That leaves us with m on its own on the left-hand side. We didn't multiply or divide by a negative, so the arrow still stays the same. And 6 times 3 is 18. So we get m is less than 18 for our solution. Question 4. Find the value of d in the diagram. This is a quadrilateral, and quadrilaterals have an angle sum of 360 degrees. So we know that d, if we add all the other angles up, that should have a total of 360 degrees. So we've set out a little equation there really. Let's simplify 91 plus 75 plus 132. Let's add up all the rest of it. And we'll get d plus 298 equals 360. And to work backwards to get d on its own here, we'll subtract both sides. 298. On the left-hand side, a plus and a minus will cancel out there, leaving us with d equals 62 degrees. So we're using that angle sum of a quadrilateral rule to work backwards and find out what the value of d is. Question 5. Simplify c squared d to the power of 4 times c to the minus 2 d to the minus 3. To multiply terms with indices, we add the indices. So for the c, if we add the indices that c has there, we're adding 2 and minus 2, which cancels each other out and has 0 really. So we get c to the 0. And with our d's, we have d to the 4 and d to the minus 3. If we add them together, we just get d to the 1. So let's think about that a little further before we round off here. We have a rule that says if any item has a power of 0, that item equals 1. So c to the 0 there, that whole thing equals 1. So we end up with one lot of d to the 1. When you've got an index or a power of 1, we don't have to write that in either. So we end up with a 1 out the front really, and a power of 1, but we just have to write down d there. Question 6. 2y plus 4x minus 8 equals 0 can be rewritten as y equals 2x minus 4, or y equals minus 2x plus 4, y equals 2x plus 4, or y equals minus 2x minus 4. So let's rearrange this. We want to get y on its own basically. So let's move numbers and terms away from the y so we get y on its own eventually. Let's move the -8 by doing the opposite to both sides. We'll +8 there. The minus and the plus cancels out on the left hand side, and the right hand side, 0 plus 8 is just 8. We'd like to move the 4x term. It's a positive term, so we're going to minus 4x both sides to move it, leaving us on the left hand side with 2y. And on the right hand side, they're not like terms, so they're just listed separately there, minus 4x and 8. And to get y ultimately on its own, we need to get rid of a 2 that is multiplying at the moment. You move numbers by doing the opposite to both sides, so we'll divide by 2 on each of those terms. Make sure it's every term there. 2 divided by 2 goes once, leaving y on its own, and minus 4 divided by 2 leaves minus 2 for the x, and 8 divided by 2, I think you'll agree, is 4. So is that one of our options? Yes, it is, conveniently. Answer B is correct in my mind. Y equals minus 2x plus 4. Question 7. Find the volume of this cone below to 2 decimal places. We have a perpendicular height of 15 meters and a radius on the base there of 7 meters. This question will involve a formula, so we'll write him on the top line. On line 2, we'll substitute all the numbers in, calculate our answer, and check our units. Formula for a volume of a cone is 1/3 pi r squared h. So we just need an r and an h to plug in there because pi is on our calculator. So we've got on the second line down 1/3 pi times r. Now r is 7, so we'll replace the r with a 7 on that second line and square it. And we'll times it by the height, which is 15. So putting that in our calculator, we get a volume of 769.70 meters cubed. Now it said to round off to 2 decimal places, so we did that. Now let's have a look at the units, just as our final thing here. We started off with meters as our original units, but we're talking volume here. So our volume units, if we started off with meters, need to be meters cubed. The volume, figures out how much air is in something. And so we've got meters cubed as the appropriate units for volume. Question 8. A 4-meter ladder reaches 3.76 meters up a vertical wall. Find the distance from the foot of the ladder to the base of the wall, correct to 2 decimal places. We're going to have to carefully draw a diagram here. We've got a 4-meter ladder, which we've got in the dotted red line position there. 4-meter ladder reaching 3.76 meters up a wall. Now we've made the wall vertical, which gives us a right angle down the bottom, and we've got a vertical distance there of 3.76 meters where the ladder reaches up the wall. Now that gives us a right angled triangle with 2 sides on it, a hypotenuse and one of the shorter sides, and we want to find the distance from the foot of the ladder, the bottom of the dotted red line there, to the start of the wall where the right angle is situated there. And so that's can be written as D there. So we're finding a shorter side in a right angled triangle, so Mr. Pythagoras is going to help us out quite a bit there. I'm going to start off with D squared equals the larger number squared, which in this case is 4 squared, minus the smaller number squared, 3.76 squared. So this is a Pythagoras question. It may not have looked like it at the start, but still turned out that way. We'll just run that through our calculator here. 16 minus some decimal or other. And we'll tidy that up a bit more, and we get D squared equals 1.8624. Now D needs to be on its own in the end to find the distance between the bottom of the ladder and the bottom of the wall. So we'll get D on its own by undoing a square, which means we have to square root both sides invisibly there. And the right hand side will end up being square root of 1.8624. Final answer, the distance between the wall and the base of the ladder there, 1.36 meters if we round it off to 2 decimal places. Now units wise we're always in meters, and we're finding a distance, so no need to change from units of meters there. Question 9. Simplify by first factorising. On the top the expression's got 3x squared plus 6x all over x squared plus 4x plus 4 on the bottom. So let's factorise the top there. What's common between 3x squared and 6x? I'm here to tell you 3x is, so he'll go out the front. Then we ask ourselves, what are we going to multiply 3x by if we wanted to get back to 3x squared? I think you'll see that we need another x. Now then we can ask ourselves, what are we going to multiply 3x by to get 6x? We'd need to have a plus 2 in there. Now the bottom is a quadratic, and so we'll have to do, well, one method is a PSF type situation here. I don't know whether you do it this way. There's a cross method as well and a number of other methods in the world, but this is how I think of it. The two numbers I'm looking for to fill in some brackets later, they need to add up to give 4, these two numbers, and at the same time they need to multiply to give 4. So that's where we look to find out the characteristics of these two numbers. So they need to have a product of 4 and a sum of 4, and I'm looking to have factors of 4 and factors of that top number, the 4, they're both 4 but still. Factors of 4 are 1 and 4 and 2 and 2. Now 1 and 4, sure they've got a product of 4, what's their sum though? Their sum is 5. So I'm going to reject the 1 and 4 pair and have a think about the 2 and 2 pair. 2 and 2 has a product of 4 if you multiply them together, and a sum of 4 if you add them together. So I'm liking those two numbers, and they're the two numbers I just stick into the brackets in that arrangement. That's how I find the factorised version of x squared plus 4x plus 4. So that'll go underneath there. So I've factorised both of those, the top and the bottom, and let's continue on from there. Now I think you'll see there's lots of brackets with x plus 2 in them. We can, if there's anything that in a fraction that we can divide into the top and bottom, we should do that. So here, let's divide the bottom by x plus 2, and it goes once, and into the top it goes once. So that simplifies things dramatically. That leaves us with 3x on the top and x plus 2 on the bottom. So that worked out quite nicely. If you factorise these types of questions accurately, often there's a satisfying section where you can cancel out whole brackets, and that makes things come down quite quickly. Question 10, we're finding the area of a triangle correct to 1 decimal place. Now this is a non-right angle triangle. We can't do half the base times the perpendicular height here. We don't have that type of information. But we have two sides and the included angle. And there is a formula for this. I'm not sure whether you've seen it yet. If you haven't, I apologise. But anyway, if you have, this is good revision and practice for you. So we might learn something here if we haven't seen these types of questions. So in a non-right angled triangle here, if you've got these two lengths and the angle that's between them, you're allowed to use this formula. Area equals half of AB times sine C. Half AB sine C. There's invisible multipliers in the gaps there as well. So it's half of A and B. Now A and B are the two sides, and capital C represents the angle. So we've got half of 47 times 52, and it doesn't matter if you get them in the wrong order because they're just multiplying, so the order doesn't matter. So you could just as easily have half of 52 times 47 times sine 77. It's got to be the angle that goes next to the sine there. So we're just substituting that underneath the positions, the correct positions in the formula. and we get an area of 1190.7. They did ask for 1 decimal place, so we'll round it carefully. And with the units, we originally had millimeters for our lengths, but we're after an area here, and so the appropriate units for area is, in this question, millimeters squared. Rounded off to 1 decimal place there. So that's interesting. If you've never seen one of them before, we can find the area of a triangle that's a non-right angle triangle. We don't have a base and a perpendicular height in this, but there is a formula for it. As long as we have 2 sides and the angle that's definitely in between those 2 sides, we can process the area there. Pretty cool.